Good morning. I'm Nikhil Vasu from the British Geological Survey. And in my presentation today, I'll be showcasing the BGS experience of the assessment of rainfall-induced landslide hazard at regional scale. And I'm presenting here on behalf of my BGS landslide team. And also like to thank LandAware for this opportunity to present this work. In the global context, UK does not experience much of this extreme climatic or tectonic events, nor have this mountainous regions associated with large-scale destructive landslides that we usually see in other parts of the world. Despite this, I mean, UK does have a high density of recorded landslides, and we see different types of landslides such as translational, rotational, flow type, landslide rock falls, both within the inland of the UK as well as along the coast. And many of these landslides have a significant impact to both the society and economy. So BGS provides a daily warning assessment as part of the Natural Hazard Partnership. So this Natural Hazard Partnership is a consortium of 19 public bodies that was formed in 2011. And the aim of this body is to mainly provide the scientific information and the research associated with the natural hazards for the civil contingencies, the government, and the responder community across the UK. So the objective of this daily hazard assessment is mainly to provide a 5-day hazard summary report related to the ongoing issues. So this table here shows the different hazard that the partners of this NHP provides the daily landslide hazard assessment, and for the landslide assessment, we usually give out only the 24 hours forecast, unlike other hazards, which kind of provides a 5-day UK hazard forecast. So for the landslide hazard assessment, like the other assessments, so there are 4 assessment levels according to this traffic light system. So we have the green, yellow, amber, and red. So green means that in a landslide context, the landslides are not likely, and there are no reports of landslides. For the yellow assessment, it means that there's some likelihood of isolated landslides, and but the impact from these landslides are very very limited or localized. And amber, it means that there's increased likelihood of multiple landslides with impact to significant population. And red, it means there's a higher likelihood of major landslide events occurring, and the impact is also very, very high. So BGS gives out this assessments based on 4 factors. So that is, we look at the antecedent soil moisture condition, that is how wet the slope is. We look at the magnitude of the forecasted rainfall. Also, we look at what are the, if any, landslide events are being reported as during the storm or other events, and we also provide look at the regional interpretation of the impact. So this slide shows the different steps that we undertake in preparing the landslide assessment bulletin. So in the first step, so we prepare, we look into the UK Met Office Hazard Manager. So this is the online viewer where we look for any weather warnings that is forecasted by the UK Met Office, and this forecast can be looked for the past 24 hours, the next 7 days, and also for the past 6 hours. So usually the team will look into the spatial extent of the warning, the validity time of the warning, and the amount of the expected rainfall. so once that is done, so in order to understand the antecedent conditions, so BGS has a model that runs to estimate the degree of saturation in the slopes based on the antecedent conditions. But that particular model mainly runs for Scotland. And for the other regions, which is not covered by this model currently, so we use expert-based approach, where we look at, we look at the rainfall accumulation from the Met Office radar data and the experts' knowledge about the ground conditions like the geology, the soil type, hydrology, and the hydrogeology. So that kind of information is kind of brought together to get an expert-based decision on the antecedent condition. So once we have the forecast of rainfall and antecedent condition, then we try to look at this, compare this with the landslide susceptibility products and also the past landslides in the region. So we do that using, so there are two BGS products to do that. That's a GeoShore landslide, and there's another product called the GeoShore debris flow. So we'll also look at the past landslides using the landslides that are recorded in our national landslide database. And currently there are about more than 17,000 of those in our database. So now in all the steps, what we mainly look is into the future as well as in the past. But when we have a particular storm or event that's happening, we also need to look at what's actually happening in the ground. So that's mainly done by BGS by looking through the social media, by trolling through social media. So we use the social media to look at the evidence for landslides through by looking at various sources like Twitter, Google News alerts, or currently we have a new tool called the Global Landslide Detector. So Global Landslide Detector is a recent tool which is developed through a collaboration between BGS, the Qatar Computing Research Institute, and the European Mediterranean Seismological Center. So this tool uses machine learning to recognize landslides in photographs from the social media. So I've put a link to that in the bottom of this slide. So all this information together is synthesized by an expert who's on NHP duty. So in BGS currently there's 5-member team for the NHP duty, and they work kind of 7 days a week. So this, so they create this alert assessment text, and it's it's emailed daily at 2 p.m. to the environmental monitoring and response center at the Met Office. So as I said in my previous, mentioned in my previous slide, that we give out, we need to understand the antecedent condition. So in this particular slide, I just want to quickly just touch base on the model that we use, and this particular model that we use in Scotland is called the BGS water balance model. So this model is mainly used to understand how the water or the soil saturation changes within a 1 meter thick soil. This particular bucket consists of two buckets. There's a macropore bucket where water can move in fast, and there is a micropore bucket where the water can be stored and the water drains out slowly into the deeper soil. So this model usually helps us to understand how the degree of saturation changes with the rainfall event in mainly for Scotland. So that information from this model is then evaluated against the forecast information from the Met Office, and we have three threshold curves that's currently empirically adjusted, and we use that to look to give information as to what the threshold levels are for based on a forecasted rainfall information. Yeah, so before I finish off, so I'd just like to show particular case study from the 2015 Storm Desmond event. So this was a storm that arrived in the UK on 5th of December 2015. It had it brought a widespread heavy rainfall, and in Cumbria mainly a lot of impact of the storm was seen. So this particular storm put about 340 millimeters of rainfall in 24 hours, and it was about 200% of the long-term average that was seen in Cumbria. So the Met Office, UK, one day before the storm arrived, on 4th of December, gave out yellow warning, and by afternoon of the same day, the warning was increased to amber, and finally on the day of this event on AM of 5th of December, the warning was upgraded to a red level. As you can see on the right-hand side bottom, there's that Twitter alert. So similarly, so what we at BGS, so on Thursday, a day before, or 2 days before this event, so we were still at green. So on Friday, we slowly upgraded to yellow. That was around the afternoon, and then until 10th of January, we remained in yellow. So the reason. So the main reason for that, for this lag, was mainly because it's a very expert-based system where we don't have a lot of information on localized variations of the ground conditions. So that's why we remained on a yellow for longer time. But in the hindsight now, it looks like the yellow assessment was reasonable, because the impact from most of these landslides, which had really small volumes, I mean, it did not cause any kind of widespread disruption to the population. So yeah, if it had a much bigger impact, then we should have gone to amber, but that did not happen. So in the hindsight, we think that the yellow warning was quite reasonable. So because I don't have much time, so I'll just like to summarize my presentation here. So BGS generally provides a daily assessment for mainly rainfall-induced landslides in the UK, and we don't provide any such type of assessment to the coastal landslides yet, but research is underway. And this particular assessment approach that we provide is very expert-driven process. However, we are trying to extend this antecedent water balance model to England and Wales, and also we are trying to research to integrate the exposure and the vulnerability model to kind of better support our decision-making abilities as part of the daily landslide hazard assessment. So thank you very much.